All right, here we're going to try to find any global extrema for the function f of x equals x times e to the negative x squared over 2 for negative 2 less than or equal to x less than or equal to 2. Now, this is our artificially defined domain of the function. As we've discussed before, we're going to take both endpoints as being critical. Whether they make the derivative 0 or not exist, we have two critical points immediately, both negative 2 and 2. Curious if we have any other critical points based off of the derivative, though. So here's our solution. F prime of x via the product rule will be 1 times e to the negative x squared over 2 plus x times e to the negative x squared over 2. Then via the chain rule, I get negative 2x over 2 here. Cleaning this up, get e to the negative x squared over 2 times 1 minus x squared. Factoring out what's in common. So f prime of x equals 0 implies that 1 minus x squared equals 0. Because this exponential is never 0. Solving this out, get x equals plus or minus 1. Okay? Good. It should be okay. Good. So recall that step 1 in our process was find all critical points. So here our critical points are, we found negative 1 and 1, but via discussion we had before, I'm also going to include the endpoints of the interval, and so those be critical immediately. So negative 2, negative 1, 1, and 2 are all my critical points. Once you have all critical points, step 2 is the table. So you take critical point, then f of critical point, negative 2, negative 1, 1, and 2. And putting these values into the original f of x, not the derivative, should give me negative 2 e to the negative 2, negative 1 e to the negative 1/2, 1 e to the negative 1/2, and 2 e to the negative 2. Now here's where decimal approximations would be helpful. If you guys could help me out with that, I'd be appreciative. This would be 1 over the square root of v. This is the opposite of it. So if I can get someone to give me just these two values, these two are the opposites. I need 1 over the square root of e, or e to the negative 1/2. I also need 2e to the negative 2, please. Say again? 0.27. Okay. Someone confirm that, please, though? Yep, okay. What about 1e to the negative 1/2? .607. So I'll go 0.61 just to keep same number of decimal places. So I see these values. Okay. Step 3 find big and little, which occur here and here. And step 4, which is a bit of a non-necessary step if you're on a closed domain, because notice all these points actually are in the domain. This is the smallest thing ever. We can say F achieves a global min at 2 ways of saying it, x equals -1, or at the ordered pair, -1, -1e to the -1/2. Depending on who's asking the question or how your homework may want to be worded, either the x value or the ordered pair where it happens. Step 2, F achieves a global max at x equals +1 or 1 comma e to the -1/2. A quick sketch of the graph illuminates this. Graph looks something like this over the entire range. Cutting it off means doing something like this. So basically erasing. From there back. The critical points we found, the plus and -1, were right here and there. And for reasons I think are clear from the picture now, we also test the endpoints. Because those are also points that might be the biggest thing ever. So again, we took them. In this case, the endpoints were kind of in the middle of the range. So they weren't global extrema. The global extrema is actually going to be the ones here. One thing to mention, looking at this example, one thing we never did and do not need to do ever is use the first derivative test or the second derivative test to classify these critical points. You simply do the 4 steps mentioned. Find the critical points, make your table, find your big and little, and then make sure those are okay. Okay?